on this page right here. This page right here. Everybody has it? Thumbs up? We there? Oh, I see some thumbs. Well, that means everybody's there. Allie, what are you doing on the ground?
I'm getting my pencil.
Okay, grab it quick. Okay, so let's go ahead and take a look at this. Now, we've done this work before. We've worked with these before. We've worked with this. We've talked about how when you have, look at this top one here that says another example at the top. See how you have a numerator that's greater than your denominator? We talked about this. We've done this before, right? Yeah. What does it mean, Sellers?
Improper fraction.
It is an improper fraction. Because you always want to have your numerator smaller than your denominator. So, that means we know that we're going to end up with, this is how we get a mixed number. Remember when we talk about mixed numbers, and I would say mixed number is a whole number and a fraction? Remember that? So in this case, let's look at this. It says we have fraction strips here. We know we have two wholes, right? And then they're each divided into 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? So in this case, you can see that 12 1/6 fraction strips, underline, circle, highlight the important information. 12 1/6 fraction strips equals 2 whole fraction strips. Visually, you can see that, correct? Does that make sense? Can you guys see that? When you have that many, you've got 12 sixths. What do you have? What do we have? Bricks. It's on there. I'm giving you a hint. Right there. Look at the picture. What does it line up with, Briggs? What does 12 sixths equal? It says it's on your page. What's the page? Savvas. That's right, 2 wholes. Now, I just told you that usually you end up with a mixed number, which is a whole number and a fraction. In this case, we did not end up with a mixed number. We end up with just 2 wholes. We end up with a whole number. Because when you have 12 over 6, look at this. Here's a hint. When you have a numerator that's greater than your denominator, look at it like a division problem. What is 12 divided by 6? What's 12 divided by 6, Sellers?
6.
What is 12 divided by 6? Jack? That's right. 12 divided by 6 equals 2. So you know right there, if you can divide evenly, then you've got a whole number, right? But look at the picture, guys. Look where it lines up. Just looking at it should be able to show you. Each on both sides, they just line up with 2 holes. You guys see that? Make sure you're looking at your page as well. It's the same thing on there. So all whole numbers have fraction names. All whole numbers have fraction names. You can write 2 as 12 over 6. 12 6, right? You also know 2 equals 2 over 1, so you can write 2 as 2 over 1 or 12 over 6. And why would 2 also equal 2 over 1? Why would 2 also equal 2 over 1? Jed? Why would 2 equal 2 over 1?
Because it's 2 wholes.
Well, it is 2 wholes, but why would the fraction, what can you call the whole number 2 by the fraction name 2 over 1? Remember what I just said about division? Ready? Remember what I just said about division? If 12 divided by 6 equals 2, and you know that 12 over 6 is a fraction name, excuse me, I'm joking here. A fraction name for 2 as a whole number, and I said 2 over 1 could also be a fraction name for a whole number. What division problem am I talking about? What's the division problem there, Jen?
12 divided by 6.
12 divided by 6, but I'm asking you about 2 over 1 now. 2 over 1 is also a fraction name for 2. Why though? Look at it as a division problem. What is 2 divided by 1? Yeah. That's right. That's exactly right. 2 divided by 1 is also 2, which means that the other fraction name for 2 as a whole number is 2 over 1. 12 over 6 also works. Who can think of another one? Who can think of another fraction name that equals to 2? We would have 2 wholes. Remember what I said, when you have a numerator that's greater than the denominator, look at it, see if you can divide them. So think about a division problem. What else equals 2 in division? What's another one? What's another one, guys? Brewer. Go ahead. Come on, guys. What's another one? What else equals 2 in division? What's another one that we could do, Rick? Is 4 thirds? Are you sure that 4 divided by 3 equals 2? Sure about that? Did you say 4 over 2? Because 4 divided by 2 is what? That's right. So that one works, right? What else works? Andrew? That's right. What else works? Aiden? That's right. That also works. What else works? What's another one? Jack? Do you mean 16 over 8?
Yeah.
That does work. That's right. That's right. That works. Andrew? Yep, 14 over 7. Table, what else? That's right. So any one of those could be a fraction name for 2, right? Because they all equal 2. And if you were to draw them out, like let's draw out this one here, 4 over 2. Let's draw fraction strips and see what happens. You got 2 1-wholes. And now we're going to draw the same thing underneath. But this time we're going to divide them, right, into 4s. And each one of these is going to be 1/4. Oops, that's supposed to be 4. So I actually did the 8 over 4 one. Right? Because look, 1/4 plus 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 1/4 equals how many fourths? How many did I just count? What is it?
8/4.
That's right, an 8/4 equals how many holes?
2.
That's right. See what I mean? Does that make sense? Starting to make sense? Thumbs up, kinda. Getting there? Okay. Trust your eyes on these ones, guys. Look at this. Again, you've got 12 6s, 12 sixths, and they line up perfectly with 2 holes. Trust your eyes on that one. Now you guys get the division part. So I think you'll get it. Let's take a little look at the guided practice section. Okay. Now, this one it says, explain how you know that 4 over 1 equals 4. Somebody explain to me how we know that 4 over 1 equals 4. Andrew? So in this case, how could we say this as a sentence? How could we say it as a complete sentence? Let's give me a complete sentence for this one. Yeah, Jack? It's 4/1, not 1/4. All right, because if you divide 4 by 1, it equals 4. Does that make sense? That's good. So basically combine what these two here said, Andrew and Jack, into a sentence. The reason 4/1 equals 4 is because if you divide 4 by 1, it equals 4. Right? So remember that, guys. That's a hint right there. When your numerator is greater than the denominator, that is what we would call an improper fraction. So let's just write about that. And you don't want it to stay improper. You want to try to make it into either a whole number, a mixed number, or a proper fraction, right? And well, it will be either a whole number or a mixed number. But in this case, in all these, we're actually turning these improper fractions into whole numbers. So that's another hint for this section. They should all be whole numbers. So let's look at this number line right here. We have 2/3 here. We know that each section here is divided into thirds. That's the goal here, is that they're supposed to be divided into thirds, right? Because they're saying thirds. So we have one there, one here, one here, one here, and one here. This is one whole. This is two wholes on a number line. Remember, on a number line, you're not looking at it's very similar to looking at fraction bars. So they're next to each other, but then you keep going, right? Kind of like it does on your ruler. When you're looking at 1 inch, 2 inch, 3 inch, it's the same thing, right? Remember how we measure things? We measure things to the nearest half inch or to the nearest 1/4. Remember when we did that? It's kind of the same thing. So if this is 2/3, what goes in the first box? What goes before 2/3? Wilkins? That's right, 1/3. What goes after 2/3? Andrew? 3/3. And 3/3 equals what?
1 whole.
That's right. What's after 3/3, Briggs?
4/3.
We have 5/3 after that. And then what's after 5/3, Jack?
6/3.
That's right. And then 6/3 equals?
1/2.
Whoa.
1 whole.
Back up.
2 wholes.
Guys, 2 wholes. It's right there. Remember also 6 divided by 3 is what?
2.
Whoa. Let's do that again. 6 divided by 3 is what? That's right. Exactly. Okay, now let's look at this one. We've got the same thing going on, right? Except this time we've got 6. It's the same number line, but this time we're looking at the other lines, not just the ones that I colored in pink. So if you know this is 3 6, then what's the first box, Andrew?
1 6.
And then what's the second box, Heston? Yep. And then we got 3 6, and then what's the next one? Jack? And what's the next one, Allie? Should be paying attention. What's the next one? Are you writing them in as I go?
I can't really see.
Or in the guided practice section, you should see on yours. Everybody should be following along.
I think it's 5 6.
You got 1, 2. Okay, we'll go. Sorry, 1, 2, 3, 4. Yeah, you've already got them written in. Why aren't you telling me? If you got the answers, tell me your answers. But you need some glasses in, or we need to switch you with Schmidt here. Okay, yes, you are right. 5. What's the next one then, Schmidt? What's after 5 6?
6, and then that's 1 whole right
there. And 6 6 is 1 whole. What's after 6 6, Andrew?
7 6.
No, 8 comes after that. What's after that, Jack?
9 6.
Briggs, what's after that?
10 6.
And what's after that, Brewer?
11 6.
And then what's after that, Aiden? After 11 6.
12 6.
That's right. But what does 12 sixths equal, guys?
2.
That's right. I told you guys would get this. We get 12 divided by 6 equals 2, correct? Yes. Now, if you get one like this, though, anywhere in between here, that's where you get those mixed numbers. Because you can't divide, say this one here, 10 divided by 6. You're not going to be able to break that up evenly, are you? Because nothing multiplied by 6 equals 10, correct? But what you would be able to tell is, okay, well, I know I have one whole here, and then I have 1, 2, 3, 4. So then you would say, okay, 10 sixths equals, one whole, that's a 1. Pretend that's a 1. And 4 sixths. That's where you get those mixed numbers. There you go. That's kind of more like a 1. Sort of. Don't follow my lead with the bad handwriting, okay? All right. So, look at this one. Look at the number line. Write 2 equivalent fractions for each whole number. Okay, 1 equals how many thirds? How many thirds? Andrew?
3.
That's right, 3 thirds. And then 3 thirds equals how many sixths? Everybody?
2.
Wait.
Wait.
You sure about that?
6.
You say it one more time? 6 sixths? Is this what I'm hearing?
Yeah.
Yes. We know that, right? Because we've seen it. We've seen it. Okay, so 2 equals how many thirds? 2 equals how many thirds?
6.
And then how many sixths?
12.
Yes, you got it. I knew you'd get it. So who here has any questions about this? Rick.
It's not a question, but like while you were going over another example,
Mm-hmm.
I went through this real quick,
Mm-hmm.
and I got all these right.
Good. I'm glad to hear that. Who else got all these ones right in the guided practice section? Yeah. Anybody have some questions about these? Anybody have confusion? It's okay. Jack?
TV?
Good. See? Well then, guys, if it's easy, it's like when I bless you. When I came over here and I asked Allie a question, I came over and looked and she had it all done. If you guys have it done, raise your hand. Tell me the answers. Well, then I'm gonna have you switch with Schmidt. We'll do that in a little bit. If you can't see the board, I gotta get you closer to the board. Okay, so now here's what we're gonna do. Like usual, I'll have you guys do the independent practice section right here. Bless you.
Thank you.
And then the homework and practice section, okay? Now I did include the back page for that one, but remember, this comes last. I don't want you guys stuck on that, so you're gonna do the independent practice section first, right here. Then the homework and practice section. Now, let me ask you a quick question here. On the homework and practice section, when you see another look, what do you do in this section right here? What do you do here, Tamba? That's right. You don't have to do anything there. You just read it. It's there to remind you of what you're doing, okay? And remember, this is the whole point of this unit. You can name fractions as whole numbers and whole numbers as fractions. Math is all about relationships, right? Yes, Andrew, go ahead. Any questions?
Can I get another mask?
Yes, you can. Briggs, question.
Where's the independent practice?
On the bottom of the section that you might have already done. Did you do this one? Underneath the guided practice?
Not yet.
Okay, that's it. So you just got a few pages. The next page. After that. Briggs, I think you're skipping pages. Which packet are you guys in?
I'm in the new packet.
I'm in the new packet too. Guys, I'm in the new packet. It should look exactly like this one. Go back to the page we just did. The one right here that says April 22nd.
Yeah.
We just did the guided practice. This is independent practice right here. Okay? The next page.
Yeah, it doesn't. Look, this is the second page of mine.
Uh-oh, did you guys get a page cut out of yours?
No, I mean, this one's after this page.
No, I also got one.
Yeah, no, that's wrong. That's wrong.
After this.
Yeah, that's wrong. Huh. Looks like a page is missing from yours. So, guys, to do the homework and practice page then, pull out your old packets. I don't know what happened in the copying process, but you guys are missing a page. No, you did not do all that work for nothing. It's the same page. All you're going to do is pull it out and add it to your new packet. Go to where it says April 20th. Not April 19th. That was the other day. That should already be done. Except you weren't here. Go to April 20th. Quick. And then pull out the homework and practice page. Thank you for pointing that out to me, Briggs. Because in my version it's there, but in yours it looks like it's not there. Yep, it's in both. Well, it should be the exact same in both. Something happened in this one. So go ahead and pull that one out. Set your old packet aside for now. We'll come back to it for the writing. No, set your old packet aside. You're pulling the page out of the new packet, out of the old packet, excuse me, and adding it to the new packet. So that's the homework and practice page. Everybody has that one now? So that's the one that you're doing. Thank you for pointing out that that wasn't there. So you're going to do the independent practice, that page, and then if we have time, we'll get to that back page. I want you guys to get as far as you can. Just don't get stuck on it. And then what we will do is, in probably about, well, we'll check in. I'm gonna go around. I'll see how long this takes us, and then we'll come back together and go through everything. Okay? Including the back page. So let's see how far we can get. So everybody should be back on this page with the independent practice. This section right here. Everybody has that one up? Everybody's got that one on their page, or excuse me, on their desk? Yes? Yes? Thumbs up? Everybody has this one? Is that one in front of you? Nope. You're not on the right page. Please turn it. This is how you guys are going to learn, is by paying attention. We're going to do this work together. I know some of you are getting it, some of you aren't. So let's do it together. It's way easier than you think it is. I think some of you guys are making your lives a lot more difficult. Nick, question. Oh, was that a thumb up? It wasn't a question? Okay. Everybody has this one open? Yes? Okay. We're going to do this together. I need everybody paying attention. Right here. I drew this one out on the board for you guys while you were working. Okay? I want you guys to look at these. There are shortcuts to these. And all you have to know is a little bit of multiplication and division. When you're working on this stuff, you can still use your charts too. Those multiplication tables. Jack. Okay, so yes, I want to know. Now, listen. All you're doing here, when you don't have the numerator, couple things. With all of these problems, what is the one thing you're noticing about the numerator? Somebody tell me. What's the one thing you're noticing about the numerator, Heston? With all the problems we're doing to get our whole numbers. They're not the same. They're the same when it's a 1. When you have one whole, they're the same. That's correct. So that means that 1 over 1, 2 over 2, 3 over 3, 100 over 100, those will all be 1. Right? But what else are we noticing here? Briggs. That's exactly right. The numerator on all of these, again, except for the ones that should be 1, the numerator is going to be greater than the denominator. It means the top number should be bigger than the smaller number. Because we're actually looking in this case for those improper fractions. Normally we would want it the other way around, right? Where the numerator is lesser than, right, the denominator. In this case, we want a greater one. So if we're looking at a problem like this, which we've already done, the one down here, and I told you to look at it as division, we're going to do the opposite here. So let's jump down to number 8 really quickly first. What is 6 divided by 2? 6 divided by 2, Alex.
3.
That's right. So you automatically know your answer is 3, even if you didn't know that 3 divided by 1 is also 3. You already know. That's how easy that problem is. But now look at this one. In this case, we have the whole number, but we don't have the numerators. So if I'm asking you to do division here, okay, if it helps you, draw these out. Draw out your little division symbol. That's a really bad one. Let me draw that again. Let's draw a better one. Here we go. It helps you draw a division next to these. Anytime you don't have your whole number, look at it like a division problem. Anytime you don't have a numerator, look at it like a multiplication problem. Okay? So in this case, you're looking at what is the whole number multiplied by the denominator. So what is 4 times 2? Brewer. What is 4 times 2? Seva. That's right. So now in this case, you know it's going to be 8 over 2 because 8 divided by 2 equals 4. 4 times 2 equals 8. But you need one more. So what can you do here? What is 4 times 1? What's 4 times 1, Wilkins?
4.
That's right. That's it. And of course, these are easy, right, Tava? What's number 5?
Number 5 is 4 fourths and 1 1.
That's right. Because you guys know whole numbers. You know the one whole number, I mean. Right? You know what happens when you have one whole. Tava. Yes. Schmidt.
Can I do number 6?
What is number 6?
For the first one, you put 6 on top of 3. And then for the second one, you put 2 on top of 1.
That's right. And guess what, guys? Because 2 times 3 is what?
9.
It's like crickets in here. 2 times 3 is what?
6.
Okay. 2 times 1 is what?
2.
That's right. 2 times 3 is 6. 2 times 1 is 2. You're multiplying with these. What is 5 times 2? That's right. Everybody should know these. What is 5 times 1?
5.
That's it, guys. That's it. Don't make your lives more difficult. That's all you have to do there. Go ahead. Right? When you don't have the numerators, use multiplication. When you don't have the whole numbers, use division. Okay? Check it out. This one we already know. What's 3/3 and 6/6? They're the same thing. What is it? What is it? Everybody should know this one.
1 whole.
That's right. 1 whole. What's 8 divided by 4?
Half.
Nope, not 4 divided by 8. Not 4 over 8. Excuse me.
2.
Everybody?
2.
Don't look at it the other way. If it was 4/8, that would be 1/2. It was 3/6, that would be 1/2. But they're reversed. In this case, 8 is on top of 4. 6 is on top of 3. So we're getting 2, not 1/2. I understand why you guys would get confused there, but it's not like that, right? Because this time, again, the numerator is breaking the rules. The numerator is greater than the denominator. Shouldn't be, right? What about this one? What's 9 divided by 3? What's that?
3.
You automatically know your answer is 3. What's 12 divided by 3?
3.
I mean 12 divided by 4.
3.
What's 12 divided by 4? Yes. Does that make sense? I need to know. Give me a show of hands. Thumbs for who it does make sense. For whom it does make sense. Makes sense, but you don't really like it? You're kind of getting there? Okay.
Thumbs up.
Okay, we're getting some. But are you paying attention or are you writing down what I'm doing? Because if you're not writing it down, you're going to hurt yourself. Okay. Did you write down multiplication division symbols next? Guys, I'm not just drawing them there because I think it's fun. It should help you if you're paying attention. Schmidt, question.
On number 7, I doubted myself a lot.
I don't want you guys to doubt yourselves.
And you know where you put the 5? I put 5, but then I'm all like, no, that's wrong. But I
don't
thought
doubt
it was right
yourself.
before, but then I just erased it and put 2.
But a 2 over 1, of course, would be 2. Right? See? Don't doubt yourselves. Go ahead and throw it away. And I said the same thing to Jack. Confidence. Yes.
The 3, 6, and the 1 thing looks like a smiley face. And number 6.
Good. It is a smiley face. It's happy because some of you are getting it.
You just made that.
No, it's totally happy. This is happy math right here.
Not for me.
I know I'm hearing some of you being very negative, but we don't do negativity in here, okay? And we don't say I can't do this. We say I can't do this yet, right? It means you will be able to do it. You just have to work on it. Yes.
This is super.
Good. Some of you think it's easy, and that's good. I want to hear that.
It's like second grade.
I don't know if it's second grade, but to a certain degree it kind of is because we've been doing a lot of multiplication division, right? I don't think you do a lot of division in second grade, but you did this year. And we did multiplication this year. And some of these, I mean, that's really all these are. That's all you're doing. And what's that other thing that I say? When in doubt, draw it out.
Yeah.
If it helps you to draw these out, draw them out. Guys, draw it out. You could draw it out. Don't doubt. Don't doubt yourselves. But if you are in doubt, draw it out. Okay? You can always draw it out. Andrew. And you kind of like it. Good. That's a good start. Jen.
I noticed the pattern on the bottom answer. It's 1, 2, 3.
It's 1, 2, 3. Yeah, you're right. It is. Bricks.
In this final class, I thought, like, close to the end of the year, you did a tiny bit of multiplication. Because,
Yeah, we did.
Yeah, you guys would have started some. That's how you guys all knew that 6 times 6 is 36. Because that was one thing I knew you guys knew from the very beginning. Plus, I know you guys know how to skip count for a lot of them because things like 2s and 5s are super easy, right? 2, 4, 6, 8, 10, 12, right? 5, 10, 15, 20, 25, 30. 10's are really easy. 10, 20, 30, 40, 50, 60. There are some that are really easy to skip count by. The other ones get easier once you remember them as well. Yeah.
one day I was watching YouTube.
Guys, shh.
And there was this YouTuber who, as a joke, said, "When in doubt, hit Chris with a truck."
Okay, well, we're not doing that. Okay, we're moving on to the next page. Everybody go to the homework and practice page. Now, some of you guys, I noticed you followed some of what was happening up here, but you didn't read it. Because you looked at it, didn't read it, and then you led yourselves astray. This says whole numbers have equivalent fraction names. Okay, we've already talked about that, right? One whole divided into one equal part can be written as 1, 1. You guys know that. You know your one wholes. You know 3, 3 is one whole. 6, 6. 100 over 100. Million over million. You know all of those are one whole, right? Because it's one part out of that many. One part out of one whole. If I cut a pizza into 2, and I gave you both parts, 2 over 2, I just gave you the whole pizza, right? Aiden, question. Okay. You can do it. Okay. 2 wholes, guys. 2 wholes. Each divided into one equal part. We were net 2 over 1. And why is that? Because 2 divided by 1 equals 2. Look at those as division problems. Look at them as division problems. And every time you have a division problem, what else can you look at it as? What's the other side of division? What's the opposite of division? Jack? Multiplication. So if you don't know your division, look at it like multiplication. And you can say to yourself, well, what can I multiply by this denominator here to get 2? Oh, it's 2. Right? Go ahead. So you can name fractions as whole numbers and whole numbers as fractions. What they're showing here, you here guys, are equivalents. These are equivalent fractions. This is not what they asked you to do down here. Okay? Hey, Brewer, turn your face. Abigail, please sit down and focus. Thank you. They're showing you equivalents here. They are not showing you what you were supposed to be doing down here. This is why it's very important to read instructions. Go ahead and sharpen your pencil. The number line shows other equivalent fractions for 1 and 2. You can see that. 6 thirds and 12 sixths line up. 3 thirds and 6 sixths line up. Right? Those line up. Let's go down into this section right here. This is where I noticed a lot of you were not paying attention to what it asked you to do. It said, complete each number line. Sixths means that each whole is divided into 6. Thirds means that each whole is divided into how many? Exactly. 3. These should be divided into thirds. Each whole. How many holes do I have here, guys, on this line? How many holes do I have there? How many holes? So there's 4. That's exactly right. How many holes do I have here in this line? On number 3? Abigail? 2. How many holes do I have here on number 4? Zoe? How many holes do I have on number 4? 3. That's exactly right. So if it's asking me to divide these into this amount, then I need to go back to each hole and divide it up. Now, each hole in this line is divided into thirds. That's it. Right? That's it. Now, if you guys wanted to mark them, that's perfectly fine. If that helps you know what they are, absolutely, please do it. You could say 1/3, 2/3, 3/3, and so on, right? All the way down. If that helps you remember what they are. And it actually might help you because now you're getting those improper fractions. 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, and 12/3. All the way down. Okay, what about this one though? I need to divide these into fourths. So how many lines do I need to draw in there to make those two holes divided into fourths? Brewer. That's right. And the goal is to try to make them look even. If they're not drawn perfectly, that's okay. Remember that your goal is that they're even. Right? 1, 2, 3, 4. And same thing, you can mark those if you want. Now the bottom one, what am I doing here, Jack? That's right. Each one is broken up into halves, right? Halves mean twos. This is what you guys should have there. And if you don't, please do it. Please make sure you've got that. Because that's what they're asking you to do. And I would like to see you guys mark them all because it will help you remember them. And then you can tell which holes line up with which fractions visually right here. If you write this down, this will help you. And I will show you why. Because look at this. Look at this one right here. You already know that 3/3 lines up with one hole, right? Well, look, 6/3 lines up with 2 holes. 9/3 lines up with 3 holes. 12/3 lines up with 4 holes. You see that? It's a pattern. Right? When in doubt, draw it out. Number lines really help with this. And it's going to be very similar when we do more measurement, too. Think about it like your rulers. It's the same thing. Right? And you can mark these the same. Again, it will help you line them up. It will help you see them visually. Trust your eyes. And look for the patterns. Okay, now, let's, because it's almost recess, quickly go through these here. We'll do the back page later, but let's take a quick look at these last few ones here. Remember, we're back on here. What did I say you have to do when you don't have a numerator? What did I say you have to do when you don't have a numerator, guys? Chad? You have the denominator. Yeah, we're finding the numerator, but how are we doing it? What did I say on the other page? Right, how can we do it? What would we call that for an operation, Jack? Not division for these. Yes, multiplication. Those are multiplication. Those are division. So these are multiplication. So we would take the whole number and multiply it by the denominator. So what is 3 times 1? What's 3 times 1?
3.
That's right. What's 3 times 3?
9.
That's right. Okay, what is 2 times 1?
1. 2.
All right, what's 2 times 4?
8.
What is 8 times 1?
8.
What's 8 times 2?
16.
That's right. What's 1 times 2?
1. 2.
That's right. What's 3 times 2?
3.
Did I say 3 times 2? Yeah, guys, I said 3 times 2. What's 1 times 3? That's true, but we're not talking about that. What's 1 times 3? Yes, it's 3. This is one, you guys should know this one automatically. 2 over 2 and 3 over 3. Right? But you can always go back and double check, too, and look at it like these. 8 divided by 1 is 8. 16 divided by 2 is 8. Right? 3 divided by 3 is 1. 2 divided by 2 is 1. So looking at that way, what is 12 divided by 3? What is 12 divided by 3?
4.
That's right. Remember what I said? They're also giving you a hint with these second ones here. They're giving you a big hint. Because look at this. What's 6 divided by 1?
6.
Yeah. Which means what's 18 divided by 3?
6.
That's right. So even if you didn't know 18 divided by 3, but you have 6 divided by 1 there, and you know that one, you already have your answer. You already have it. 5 divided by 5?
1.
Those are 1. What is 5 divided by what? That's right. That's it. Did everybody get those?
Yeah.
You feel pretty good about it? I know some of you are still a little confused. We're going to continue working on it, okay? Now, we didn't get to the back page, but it is recess. So we will touch base again when you guys come back. Go ahead and leave your packets where they are. Grab your masks. And everybody go ahead and recess.